All right, here's another example of using the ratio test to find the interval of convergence. Here's one that looks pretty complicated. This is problem 20. The sum from n equals 1 to infinity of n to the fifth power x to the n over 3 to the n. All right, well, as always, we'll use the ratio test. We'll find a sub n and a sub n plus 1. A sub n is just n to the fifth power x to the n over 3 to the n. That is the exact expression they give us. To find a sub n plus 1, I replace every n with n plus 1. So I'll have n plus 1 to the fifth power, x to the n plus 1 over 3 to the n plus 1. I don't know about you, but I don't want to multiply out n plus 1 to the fifth power, so let's leave that as n plus 1 to the fifth power. X to the n plus 1 is x to the n power times x to the first power. When you multiply the x's, you add the exponents. And similarly, 3 to the n plus 1 power is 3 to the n times 3. Again, when you multiply the 3's, you add the exponents. So we need to find the limit as n approaches infinity of this thing, n plus 1 to the fifth, x to the n, x over 3 to the n times 3, divided by this thing. So I'll flip and multiply. That puts the 3 to the n in the top, and the n to the fifth, and x to the n in the bottom. All right, so let's see what cancels. X to the n and x to the n cancel. That's good. 3 to the n and 3 to the n cancel. That's good. X over 3 is a constant as far as n is concerned. So let's pull x over 3 out here. And let's see what we have left now. I have x over 3 times the limit as n approaches infinity of n plus 1 to the fifth power divided by n to the fifth power. But that's n plus 1 over n to the fifth power. N plus 1 to the fifth over n to the fifth. And as n goes to infinity, this expression goes to 1. Because it's in the form infinity over infinity. If I use L'Hopital's rule, it'll just be 1 over 1. So as n goes to infinity, this goes to 1. 1 to the fifth power is still 1. So x over 3 times 1 just gives me x over 3. Remember, as I mentioned in the previous video, I'm leaving out the absolute value signs till now. To make this converge, I need L, the absolute value of x over 3, to be less than 1. That means I need negative 1 to be less than x over 3 to be less than positive 1. Multiply by 3 everywhere. Negative 3 is less than x is less than 3. So I know the original series is convergent as long as x is between negative 3 and positive 3. But I don't know what happens at those endpoints. So let's plug them in and see what we get. If x equals negative 3, I have the sum from n equals 1 to infinity of n to the fifth power times negative 3 to the n power over 3 to the n power. And I'll think of that as n to the fifth power times negative 1 to the n power times 3 to the n power over 3 to the n power. If it's not clear what I did, I just wrote negative 3 as negative 1 times 3 to the n power. which is the same as negative 1 to the n power times 3 to the n power. But now the 3 to the n power in the top and the 3 to the n power in the bottom cancel. But notice n to the fifth is in the top, not the bottom. So this series is going to be a bit of a mess. This is going to be negative 1 to the fifth power plus 2 to the fifth power minus 3 to the fifth power plus 4 to the fifth power. This is going to get very large very quickly. This diverges. So no colored in circle here. If x is positive 3, it's a little easier to see that it diverges, because in that case, I have n to the fifth power times 3 to the n power over 3 to the n power. Those cancel. This is just the sum from 1 to infinity of n to the fifth. That is 1 to the fifth plus 2 to the fifth plus 3 to the fifth plus 4 to the fifth plus 5 to the fifth. That's rushing off to infinity. So this one also diverges. So essentially here, we have only values between negative 3 and positive 3 for which this power series will converge. Let me say one other thing. If this seems a little fishy to you that I know this diverges, you could always use the alternating series test, because this is an alternating series. But the limit as n approaches infinity of n to the fifth power is infinity. Infinity is not 0. So this series definitely diverges.